And if you didn't know, this is based off of a grant from the National Science Foundation. And just a part of the disclaimer, we want to give a shout out of thanks, first of all, to NSF for funding this effort. And also any opinions, findings, or conclusions in the seminar, those are the views of the authors, the presenters, and don't reflect the views of the National Science Foundation. We are really thankful for them to support this work. Our first panelist is Michaela Parker. Dr. Michaela Parker is the founder and executive director of the Academic Data Science Alliance. ADSA is a professional network for academic data science leaders, practitioners, and educators. This organization supports community-driven resource development and sharing of approaches for the thoughtful integration of data science and AI best practices in higher education. Before launching ADSA, Michaela worked for the Moore Sloan Data Science Environments and was an executive director for the University of Washington's eScience Institute. She has experience promoting data science, developing and promoting data science research and training programs, strategic planning, and fiscal oversight. Prior to entry into data science, Michaela was a research science at the University of Washington's School of Oceanography, where she earned her PhD. She has managed the Center for Human Health and Ocean Studies and was involved in large interdisciplinary projects, bridging oceanography and genomics. So really glad to have Michaela here today. Our next panelist is Dr. Crystal Tsutsi. Dr. Tsutsi is an Indigenous geneticist bioethicist and assistant professor in the School of Life Sciences at Arizona State University. As an advocate for Indigenous genomic data sovereignty, she co-founded the first United States Indigenous-led biobank, a 501c3 nonprofit research institution called the Native Biodata Consortium. Her research can be encapsulated into two main foci: Indigenous population genetics and bioethics. In particular, she focuses on bioethical engagement of Indigenous communities in genomics and data science to build trust. As a whole, her interest is in integrating genomic and data approaches to assess Indigenous variation, contributing to health inequities. Dr. Greg Goins is our third panelist, and he's a professor of environmental biology at North Carolina A&T State University. Dr. Goins' research interests include systems biology and dynamic modeling of ecological systems. The central themes of his research projects are high throughput data collection and ecosystem model predictions. He's also a former program officer of the National Science Foundation in the Division of Undergraduate Education, worked with various programs, IU's Noise STEM, just to name a few. And a few years ago, he was named one of 11 people recognized in the nation by the White House as a champion of change for HBCUs. His research has been funded by a number of institutions, and he's a PI of an NSF-sponsored Includes project on building diverse and integrative STEM continua using socio-environmental systems in and out of neighborhoods, AKA discussion. That's actually an acronym. How cool. And he likes to use culturally relevant socio-environmental frameworks across all various institutions, including HBCUs. So I just want to give a thanks to our panelists for being with us today. And first, to kick us off, we have Dr. Parker.
Thank you so much, Talitha. Let me see. I need to share my screen. All right. All right. Hopefully you can see my slides. Hello, everyone. Thank you for joining us today. As Talitha said, I'm joined by my colleagues, Dr. Crystal Tsutsi and Dr. Gregory Goins. We're going to tell you about a project where we work to build communities for student success in environmental data science. This is a project that we did with environmental data science instructional leads at minority serving institutions, specifically HBCUs and TCUs, and you'll hear a little bit about our findings from those ongoing conversations. And also, as Talitha mentioned, this project is funded by the NSF and IU's grant. The title is right there. But before I dive into that project, I wanted to give you just a little bit about the Academic Data Science Alliance in case you're not familiar with us. ADSA or ADSA, we are a community of data science researchers and educators, much like many of you. who take responsibility for a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. Now, if you have your phone out, there's a QR code on this slide. You can snap that. It'll take you to our website where you can learn more about our events and activities. And I forgot to mention this earlier to Talitha, but I am happy to share these slides as well, so we can make those available to the audience. So who are we? We're a very small staff on the back end, just myself, Megan, Steve, Stella, and Veronica, but we support and are supported by a very large community. So this is a photo that was taken earlier this year at our Data Science Leadership Summit. It was hosted at Boston University. And I don't know if you can see my pointer, but that's Talitha back there. And what I really love about this particular photo is that just by chance, the folks that sat in the front row represent a diversity of different types of schools that we have in our community that we love to support. In the front row on the far left, that's Jason Black. He's at Florida A&M University, an HBCU, but next to him is Rachel Saidi. She is at Montgomery College, that's a community college. And then we have folks at University of Wisconsin-Madison, Boston University. Over on the right, that's Dia Das. She's actually in industry. And next to her is Leah Shanley, who's at a research institute. So you see, we have quite a diversity of types of organizations and schools, and they're all part of our community. So it makes us very strong, and we really appreciate their work. So just briefly, as basically a professional society for data science and academia, we of course have a lot of events and meetings. I just mentioned that Data Science Leadership Summit. That happens every spring in the May, and it's mostly for heads of data science programs, deans, chairs of departments who run data science programs or initiatives, degree programs or otherwise. We also have a bigger meeting in the fall. We just finished that 2 weeks ago, our ADSA annual meeting. It was at the end of October this year at the University of Texas in San Antonio. We had a lot of fun there. I hope that you all will join us next year. We haven't yet decided where it will be, but it will always be in the fall. And that meeting is open to a greater, wider community. We invite students, faculty, staff to come and present their work, either research or pedagogy. We also do some regional roadshows. We run workshops. I won't get into all the details, but we do have a lot of programming. So I encourage you to sign up for our mailing list to find out more. I just wanted to highlight, we also do a few online events. Here I'm showing the header for our career panel series where we talked about data journalism. And that career panel series, it's once a month, and it's hosted by a subgroup within our organization called the Career Development Network. So if you are an early to mid-career data scientist in academia, I strongly recommend you join us. A membership is free. Again, another QR code so you can find out more about this group. There's a newsletter that is chock full of job and funding announcements. It's a fun interdisciplinary community, and we offer professional development and mentorship and leadership opportunities. Okay, so, with that, let's get into the project. As you can see, this project had a lot of different people from different organizations take part. We're very thankful for their engagement. And then I want to also highlight our working group members. So we had environmental data science instructors from HBCUs and TCUs. So I'm listing here the actual universities and colleges that were represented in this work. And we really appreciate the time that they put into this project. So just a little bit of history where this project came from. Back in 2019, there was a conference that examined equity, inclusion, and accessibility at the intersection of environmental and data science fields. And a subset of folks from that conference launched the Environmental Data Science Inclusion Network. And then discussions among members in EDSIN, the Environmental Data Science Inclusion Network, resulted in ideas and eventually a proposal that was submitted and funded by NSFIUs, which is how we got to where we are today. So briefly, the project goals. The first goal was to identify the unique assets that HBCUs and TCUs bring to environmental data science education, and also the barriers to adoption of data science in teaching relevant courses. Our second goal was to identify and raise awareness of the resources and other assets available through existing organizations. For example, the Carpentries, or my organization, the Academic Data Science Alliance, that support equitable data science education. The third goal is to promote relationship building. So we really wanted to focus over the 1.5 to 2 years of this project in bringing folks together from different HBCUs and TCUs together just to have those conversations, build the relationships with the hope that in the future they can together work toward co-creating culturally specific curricula with their peers. And finally, we put all of these conversations together into a draft recommendations report. I will give you the link at the end to contribute. And we did this all together. So we hope to enhance student success in environmental data science at these institutions. So just a brief timeline on how we got to where we are. This all started in the fall of 2021, where we made invitations for these 2 working groups. And then end of 2021 through spring 2022, we held working group meetings separately. So the HBCU working group had 4 meetings and the TCU working group had 4 meetings. But then at sort of the later spring and then into the fall of 2022, so just the end of last year, we brought the 2 working groups together. We hosted a few mini workshops and pulled all of that together. What's not shown on this slide is the leadership team then spent some time, significant time, taking all of that information, all those notes and conversations and feedback, and created that recommendations report. So we did that writing at the beginning of this year and then released it in the summer. So a little bit about how those conversations were framed. We used the SOAR framework. So if you're familiar with SWOT, it's a SWOT analysis. It's very similar. SOAR is a little bit more optimistic. It stands for strengths, opportunities, aspirations, and results. So what we did was we used the SOAR framework to ask, what are we already doing well? What could we be doing more of? What do we aspire to be in the future? And how will we know when we get there? And so we used that framework for our working group discussions. You saw all those meetings we had. None of those were recorded. We wanted this to be an open and honest conversation that was fluid and didn't make people feel self-conscious about being recorded. But we used collaborative note-taking to really capture all of the cool ideas and discussion and sentiments. And then in addition to that, we used some of those discussions to create a feedback form that we then circulated to the full community and collected more information that way. And so on the right-hand side of the slide, I'm just showing like a screenshot of some of the sentiments captured in that feedback form. So what soared to the top, I'm just going to very briefly go over some of the aspects, some of the things that were identified as most important in common with both groups. So both the HBCU working group and the TCU working group felt that, for example, treating and recognizing students as scholars, not just research assistants, but as colleagues, was very important to their success. In addition, both groups agreed that a strong math background should not be required. So in other words, early exposure to data science core concepts and providing pathways should be a focus regardless of the math background of the students. Data sharing, data use, data needs, these are all really important topics and conversations in both working groups, but they had slightly different nuances. So the TCU working group specifically called out sharing data in culturally appropriate and ethical ways and Indigenous data sovereignty as important aspirations in the future, whereas at HBCUs, they were more focused on the importance of trust, so that there is trust that the data being collected is used for the people and for social good and not extractive. And of course, both communities also really recognize and appreciate the integration of community and how important that is to student success and to increase learning. So how do we know when we get there, right? The results part, what were the relevant indicators of student success? And again, this is both working groups felt pretty strongly that these were some of the top indicators of student success. One is that we see a movement towards inclusive curriculum and access to education. We see increased degree and career opportunities. We see improvement in student knowledge and skills, of course, but also student confidence and student well-being. Also important is community collaboration and understanding that we increase those engagements with our communities. And the TCU working group also noted that it was an important indicator when we see opportunities for students to give back to their communities. And at HBCUs, for students' success, it's important to have signals of autonomy and legitimacy. On the right-hand side of this slide, this is just the top of a bigger figure. I couldn't fit the whole thing in. That is also in that recommendations report I'll share the link to soon. So you can see the full rundown of all of these indicators of student success. So I want to wrap up here and let my colleagues now jump in. What's next for us? This recommendations report is still a living document. So even though there's a version on Zenodo, the link right here takes you to a Google Doc that's open for comment to the public. And so as you're listening to those of us who have been in this project talk about what we found, if you have a different perspective, or if you agree with something or disagree, please drop your comments in that report. That it is meant to be crowdsourced, and we're hoping that over the next several months we'll get more and more of these comments, and then the goal is at the end of 2024 we'll finalize a version that includes all of those all of the comments that we've had from the public. So there's a tiny URL, and I put this in italics so I wouldn't forget. Also in that recommendations report and the appendix at the very end, there is a resources list. So I mentioned one of the goals from the project was to collect resources from agencies and organizations doing similar work or providing resources for education in the environmental data science space. And so you can check that out if you go to that URL and scroll to the bottom. And I think that is it for me. So I'm going to now turn this over so you can hear from Drs. Crystal Tsosie and Gregory Goins about their perspectives and findings from our conversations with HBCU and TCU instructors. So I'm going to stop sharing, and I don't know who's jumping in now, Crystal or Greg?
Yep, Crystal. Thanks so
Great.
much, Michaela. Appreciate it.
Hi everyone. Jag är tjejen Dr. Crystal Tsosie. Thank you so much. It is my honor always to speak in front of this audience to talk about TCUs and the future, especially as it relates to indigenizing data sciences, environmental sciences, and all sciences. So right now, I'm currently at Arizona State University in an assistant professor capacity. I'm actually formerly a TCU instructor and researcher at a tribal college and university in the Dakotas. So I speak primarily from these experiences, and also I'm absolutely honored for all of the individuals that were part of our TCU working group and our Indigenous working group at large. I first want to start off with a bit of a framing. Oftentimes this is coded and formed a deficit framing in terms of Native Americans being severely underrepresented in STEM fields. I want to switch that narrative to more of an asset framing model, in that we have the highest numbers yet of Indigenous data mentors and the highest number of PhD trained and master's level trained Indigenous data scientists at all major institutions, including TCUs, to train an even larger cohort of Indigenous data science leaders. I also want to highlight one of our strengths, which is one that was pervasive through all the different working groups and comments and findings, that a key strength of TCUs is our culture. So TCUs foster our cultures, languages, and traditions to the success of our TCU students. Compared to this, 86% TCU students actually complete their chosen field of study, compared to fewer 10% that go to mainstream universities, really showing the importance of cultivating culture, inclusivity, and representation of our faculty members at these different stages. Some of the key project goals were to identify assets and barriers of TCUs and environmental data scientists, identify and raise awareness of resources, promote relationship building and collaboration, and co-develop recommendations. What we've really asked is, how do we leverage our existing strengths? And how do we exercise these strengths and extend it beyond just the circle of partners and our administration, our faculty, to also include students having a vocal role in these processes. After all, it's for them that we are cultivating these environments. We actually adapted a figure from a paper that talked about environmental or data sciences as a whole, but really focused among discussions what's the role of Indigenous sciences and community roles, Indigenous knowledges and ecological knowledges and wisdom in this space. And what we decided was that we actually have to embed these sciences at all levels for both environmental and data sciences. And really, when we incorporate these worldviews, we are actually thinking about building towards more justice-focused models that innovate all levels of health, thinking more along this One Health model, that the health of our kin and the data that surrounds us also informs human health, and also that of sustainability in terms of climate justice and social innovation and justice and change. So we also realize that a strength of ours is actually that because we are largely located in remote areas in tribal communities, that we actually have incorporated, embedded, an enriched series of online training modules through our LMS systems. So this actually provides an opportunity to extend those remote training opportunities. And indeed, unfortunately, we had to during COVID, and that has also elucidated some challenges and some opportunities for extending online training modules from that front. In terms of logistics and working with communities, there are a lot in that. There's always questions about how other universities, IRBs, and will innovate with tribal regulatory structures, because not all of us have an IRB in place. Many of us have, tribal nations have research review boards. Funding is always an issue because a lot of us requires a terminal PhD in order to serve as PIs of our own awards, and many TCU faculty members require only a master's. Let's see. So we really had to think about expertise at the level of the TCU and the faculty, as opposed to the experts of outside partners. A question, of course, is longevity. How do we ensure that the aims and the programs that we're developing are sustainable after the grant period ends? IP is a concern, especially as it relates to Indigenous data sovereignty and cultural knowledges and ecological knowledges, because some things are not meant to be shared, and making everything publicly and openly available is not always a solution for us for some things that are meant to be sacred or held local to the communities. And also just understanding that faculty members at TCUs operate on 9-month appointments and have 100% of their time is devoted to training. So there's really not much time left over for writing grants or for other research opportunities. So this is an opportunity to work with collaborators that understand these challenges and to work with us to build more degree programs at the higher levels beyond just undergraduate. This also speaks to a philosophy. We talk about, of course, data tables being relational, and also the importance of computational and programming languages in this space. We also talk about data as being complex, layered, and interrelated. And this actually translates to how Indigenous peoples have converse about data and having relations and kinship to the data. And this actually extends from now, not just like ownership models of data, but we're talking about sharing data and knowledges and wisdoms, really talking about stewardship. And this has a lot of implications, especially as we're talking about grant funding and intellectual property. This is also an opportunity to think about data as the resource that it is. I want to remind everyone that much of our lands and our resources have been stripped away from us, such that we have lost now over 99% of our lands. But if we consider data as the resource that it is, we can actually bridge these types of opportunities so that we can build local economies as rooted in data science and also in the STEM fields. And so this is kind of what the structure that the vision that many of us have in terms of intercalating Indigenous data sovereignty and also digital sovereignty in this space. So it starts with Indigenous data leaders, research capacity building and training with our students and our faculty, structuring on top of that law and governance, building physical repositories, and also developing our own data infrastructures with servers and digital data tools, as bringing in newer forms of machine learning models to help us with creating more secure data sharing platforms that are culturally consistent and also consistent with our concerns related to sharing sacred and also privileged knowledges. Then we start thinking about the future, building cloud solutions and really building and training a local workforce. So we're not talking about exporting our knowledge and experts all the time, but really bringing them back a center of a home, allowing them to build their families and their training opportunities without having to leave their communities. And that's how we build a sustainable future moving forward as rooting in data. So this is a definition that we have centralized, that data sovereignty is the right of Indigenous nations and people to exercise authority, agency, and autonomy, protect related to their data, and remind all that this is culturally defined and intrinsically defined by the community. It's not to be defined by others. But we really start asking the questions, where is the future of Indigenous data science headed? Yes, of course, we want to increase interest in data and advance data science education. But once we start building a bolus of Indigenous data scientists and leaders, we really start thinking about hosting and building these physical structures for ourselves and these research infrastructures for ourselves. And of course, the question is what is the future of Indigenous data science? This is actually a summary of responses of strengths from our TCU working groups, and really faculty kept listing that the members of our working group and some faculty at large at TCUs really understand the unique cultural and community challenges and really tailor the research and training experience to the students as grounded in fostering the future leaders and community experts that they are. So really thinking about flipping the expertise dynamic, treating students as the burgeoning experts they are, and building cultural models that value place-based learning. And that this is how we build, think about more holistically these partnerships centered first in our institutions of learning, to also then our communities and our future leadership for our tribal nations. There are many opportunities for partnerships. One, we could think about building programs for TCU students to bridge those opportunities to other institutions that have PhDs. We can foster these types of partnerships through directed grants. Of course, taking advantage of online module development, virtual training. We've also started bridging Indigenous data sovereignty and artificial intelligence modules through Carpentries and also the UA Native Nations Institute, and really thinking about locally held training opportunities through EPSCoR and also Digidata. I just want to thank everyone on the team and also our partner organizations. There's my contact. Yeah, thank you so much.
Wonderful. Thank you so much. And so if anybody has any questions, feel free to put them in the Q&A. And now our third panelist, Greg, take it over.
Hello, everyone. I really enjoyed the first two slideshows by Crystal and Michaela. And Dr. Washington, what's the time situation? I just want to make sure.
As always, it is thin, but for you, go for it.
Okay. All right. Well, I'll stick to what we originally. I didn't know if you needed me to concatenate anything, so that's okay. All right. So here we go. So I have to share my screen, and hopefully you can see my screen. And my name is Gregory Goings, and I am a professor of biology, also a professor of crop science here at North Carolina A&T State University, the largest historically black college, publicly land-grant college in the nation, and also the largest university as far as producing African Americans who go on to in the fields of agriculture. Speaking of which, one of our famous graduates now is an environmental EPA administrator in the Biden administration who came from the A&T Environmental Studies program. His name is Michael Regan, and he came from A&T, and he was in my program here, or our program, Environmental Studies. So we must be doing something right, and I'm going to tell you about some of the things that Michael went through that helped, and we've been working on for a few years. Okay, to set this up, this is a program that we have called the Discussion Network, and it's about systems learning, thinking about particularly biological systems, environmental systems in a systems thinking framework, because there are obstacles out there that negatively impact low-income students' opportunities to compete academically in STEM. We're all aware of that. But at the same time, STEM education provides the critical link between our nation's secondary schools and society. And so this is an issue that we've been working on for quite a while. You can see we're funded by NSF. And so NSF knows we need, if anybody from National Science Foundation is on, you are very aware that we need a diverse, well-prepared and innovative workforce, so that everyone is included. And but at the same time, in this very day, in the year of almost 2024, fewer than 40% of students entering college who major in STEM complete the degree in STEM. I'm not saying they don't graduate, but they do not finish in the field they intended to start with. Okay. All right. So I got a question for, we see we have 40-some participants out there, but here's the current situation at hand. Who is responsible for teaching data science? Okay. What data science are they teaching? A little bit of Socrates here. So what does it mean to be data science educated in the 21st century? I don't know. I mean, I think if we poll all 41 of us, or how many people's on the line, I think we all might have a different view of this. And so this is good that we have the AU Data Science Initiative to help reach convergence on this issue, because for the 21st century, like I said, we need to have these collaborative efforts between the NSF and HBCUs and TCUs. So we have a strong record of success with some of these audiences I've already said. So, but I would tell you this, you need champions of data science. And they are not all teachers, although I'll talk about that in a moment. First of all, if you're talking about grades 5 through 8, that's what we concentrate on right now. We have what you call bubble kids. Bubble kids are kids, I guess I could have been one if I thought about it. A bubble child is someone that's gifted, or how can I say, they show a lot of promise academically, but with little effort. Okay, and some it doesn't have anything to do with intelligence. We're all intelligent. It's just that the way they understand mathematics, it's not a steep slope. But those students at the same time with their family, they might, or their neighborhood or their environment may not be conducive to them to try harder. So that child, we found, and national studies show this, can go either way. They could never go to college, or they could be the valedictorian. It all depends on what type of exposure they have, like at the AU Data Science Center. And it's a lot of bubble children out there. And we want to capture that. So thank you, Dr. Washington, and your team for working hard on this issue. So it depends on the school districts, the college of education, whether if you're a Spelman, you need research experience, actual hands-on, I'm gonna talk about that. Then we need stakeholders. We have a lot of stakeholders. NSF has a lot of funding associated with this, like with Cubes, BioQuest, the former Synthesis Center in Tennessee, NIMBIOS, and of course the current AUC Center. So we're so glad that this is here and working hard. And notice though, there's a lot of collaboration on this picture. We all can't do this alone because it's a tough issue to get more students that are into data sciences and appreciative of the power that it yields in the 21st century. So here's some first assumptions about true literate. Okay, so I've established in the first few minutes we need a workforce literate in mathematics and science, and that's what's going to drive successful innovation, create more jobs for all citizens. So it's largely a workforce issue if you think about it, beyond just equity. Teachers. We have discovered that teachers are the key to improving students' performance in math and science. And so, therefore, you do need a well-prepared corps of teachers. That's central to the development of a STEM literate student population, particularly amongst the underserved audiences. Okay, so I'm not going to read all of this. So we've been working using data science and using models, creating real-world problem-solving framework, so students can help their communities become more environmentally sound and sustainable. So a lot of times when you talk about a mathematical model, students tend to get very nervous. I know I did, but everyone uses mathematical models every day. Go to the grocery store and you're in a hurry and there's several checkout lines, right? Well, you immediately run a model of like, okay, if this line is shorter, you predict that line should go faster, but not always, okay? So you're running a mathematical model. It's just that some of the hieroglyphics of math and things you're not applying in your head, but we all apply models. We don't know that line is going to be shorter. We just predict that, and we just have to forecast. But see, the mathematics, you can do that for a career and have a well-paid career in order to do forecasting and using data science. And then we use innovative strategies and system thinking. And the key is we use a lot of off-the-shelf resources. In other words, affordable things that teachers can buy out of Dollar Tree. We have other stores, the dollar stores. We actually have a relationship with the Dollar Tree Corporation for using some of the things in the store that we model, the vessels and things, and they provide and donate a lot of things. Ultimately, we have representational models that help students make the connections in terms of the environment and system thinking. And then, of course, we're adamant about broadening participation. So if you look at this, as we look at math and data science as it is, when a student enters a typical math class, particularly if you're in calculus, a differential equation can look very intimidating. And but the idea is very simple. It's basically looking at how the rate of change in one variable is related to the other variables. So we break it down to its component parts of systems. We have an actual physical system, then we have a model of the system. And that's what modeling is all about, is you have numbers, you might not know the truth. Okay, all models lie, L-I-E, and some are useful, okay? So you have the physical model and mathematical model, and we look at the analytical solutions and we do some computer simulation. So ultimately, our goal is to develop students' capacity to understand and solve problems through innovative use of emerging computational technologies. So the words do not jail you, because words can jail people if you're very intimidated. It involves concept maps, compartmentalization and visualization, looking at factors and relationships between factors, and we do it mathematically. Okay, and that involves, of course, it gets into solving equations using computer tools to do that. And then students, grades 5 through 8, already viewing and higher order learning, they're interpreting, the results. Rather than saying bubble A, B, C, or D, they realize there's not one answer because it is a model. But if you're able to defend that, you essentially are a full-fledged scientist using the scientific method, having data as evidence to support your conclusions. And then, of course, you can go back and check it by using parameter estimation and sensitivity analysis. So at the end of the day, here is, we have something called, you can go now if you're a teacher, if you're out there, called the Food, Energy, Water workbooks. and done by North Carolina Central and North Carolina A&T. North Carolina Central is a major HBCU like A&T, about 50 miles away. So we work quite a bit. And they're hosted on the Cubes BioQuest website. You can type in discussion network Spence Goins and Cubes, and it'll come up. You don't have to type out the URL here. So, but anyway, thank you, AUC Data Science Initiative, for allowing me to talk about how we do looking at environmental decisions and the food, water, energy nexus, and involving all these things, modeling and simulation, and then we bring in policy and social justice. So it's a lot more to it because it's all connected. But for this brief moment this time, I just wanted to share this. So thank you very much.
Wonderful. Thank you for your thoughts. And I love your data science version of Socrates. Love the questions and I love the homework. So thanks so much. So at this time, if anybody has any questions, either put them in the Q&A. I might even grab them from the chat. And for right now, what I'm going to do is I'm going to read the results of the poll. So the first question was, what is your status? If you're a currently enrolled student, 30%, and graduated working professional, 70%. And if you're a student, what level of you? We have a few freshmen and sophomore, master's, PhD students, and not currently enrolled students, about half. And your gender, we have about 70% female and 30% male. Where do you currently live? Well, 48% of us live in Georgia and 52% do not. So welcome to Atlanta. And so we asked, how many tribal colleges and universities are there? And so let's see, 52% selected, 35 accredited TCUs operate more than 90 campuses and sites in 15 states. And I believe that is the correct answer. And we asked the question, the earth is 71% water. How much of this do humans use? Now the top answer. I'm waiting for Tommy to tell me if I'm right or wrong on these answers. The top answer is humans use only 37% of available water. Is that right, y'all?
Now, I'm about to chime in.
Chime in.
Now, most by far is salt water.
Uh-huh.
So when you talk about fresh water, it's more like the 1% if you compare it to fresh, of all the water on Earth.
And that is the correct answer.
Woo! All right, fantastic. Oh, that's how it goes. Great. Well, thank you. And I'm looking for the chat. If anybody in the audience has any questions for the panelists, you can put those in the chat or put them in the Q&A. So, Michaela, let's start with you. So with this project, what was the most surprising, let's say, aspect that you learned from the project between the tribal colleges and the historically Black colleges?
That's a tough question. Most surprising. I guess I'm going to answer slightly differently. I'm not trying to be a politician. I might not answer your question exactly. I think for me, maybe not surprising, but probably something I haven't thought of nearly enough, and something that was a little not disappointing, but it made me really want to get more involved and think about how I can help more, is just the funding landscape and how tough it is. We heard from Crystal, for example, that it's difficult just to even become a PI on a grant. And then there's all these competing challenges in the communities for the faculty, the amount of teaching load, it's hard to fit in other work. So I think that ecosystem, and, I'm sure there's also all kinds of challenges at HBCUs and trying to get funding. Talitha, you have been amazing at AUC and the money that you've secured. So congratulations. But I would love to think how we can just support financially the TCU and HBCU communities to build up data science programs. I think that's, and recognizing all of the cultural and community challenges that go along with that. So that was one of the things I think we put near the end of our recommendations report was, hey, NSF and other funding agencies, here's an opportunity to elevate tribal communities and create a tribal consortium like the AUC, right, for HBCUs? And also, how else can we support HBCUs generally?
Fantastic. And, I give a shout out of thanks to Microsoft. Microsoft just funded us to do a mini grants programs for HBCUs. And our focus will be on those who haven't received significant funding to get more folks in the game, so to speak. So yes, it takes a lot of work, and it's fun. It's the team that makes it all happen. Greg, somebody put a question in the chat. They said, "Great presentation," and that's everybody. Can you talk a bit more about how you use your framework for undergraduate courses?
Yes. What you do, you have to break the component parts down. Okay. So you have which, if anything, think of an aquarium. If you're thinking about an environmental system, think about an aquarium with fish, right? Okay. You got structure, the water, the tank, the rocks, okay. But then you have behaviors called, oxygen fusion and, rate constants between nitrate going to, nitrate and ammonia and all those things. So those are the things in science that we study. Those are processes, better known as behaviors. But ultimately, it's the function of the whole aquarium to keep the system alive. And so once you break down a biological system to look at, and for environment, because environment is an ecosystem, so it's all interdependent. And so we just be able to use mathematics and data science to be able to relate it to things that people already know, because they know fish swim, rocks sit, lungs breathe, right? So, but once you feel comfortable with that, then you're not so intimidated by some of the, like I say, the hieroglyphics of data science. I'm not even sure if I answered the question.
It's great. Yes. Yeah. Real insightful.
Okay. Thank you.
Thank you. Crystal, somebody asked, first they said, thank you for the talk. They said, can you share more about this TCU biobank? And I know that's a huge question, right? So, well, what can you tell us about the TCU biobank, and what are the challenges and or opportunities that may exist around or through this biobank?
I'm sorry, I've already addressed this person's question directly on LinkedIn. I want to say that there is no planned TCU biobank. This is a future oriented goal. There needs to be a lot of conversations that have to be placed within the context of many different tribal communities first, and then they had to also work together if it's decided this is something they'd like. But this is something that may be down the line in the future. Other than that, I don't want to comment on it. Thank you.
Fantastic. Thanks so much. And y'all just comment whatever you'd like. Fantastic. So somebody says, will there be any research partnerships with the Hampton University? I love Hampton. Since they once had a Native student population. And the person says, my great-grandfather was class of 1900. Wow, just a few years ago. Anybody have any thoughts on this?
Please send me an email. You said Hampton University?
Hampton. Mm-hmm.
So that means that your, I think it said great-grandfather. That means that they were contemporaneous with Booker T. Washington when Booker was getting at his prime in Tuskegee. But guess who produced Booker T. Washington? It's Hampton University. And so this would be, historically, that would mean a lot if we can find out a way to work with Hampton as much as possible. And one of my best mathematicians on campus is a Hampton graduate. So Dr. Washington, make sure everyone sends out an email. So I welcome that.
Yeah, that would be super cool. And there's so many different connections across the institutions. And for everybody on here, I know you all said you share your slides. So what we could do is we can do an email out of the slides after the webinar for the attendees. Thanks so much. Great. So Michaela, how do you see this future of data science in higher education? So Greg gave us some high level questions, and so that I can do my homework appropriately. What are your insights about what it should be, how it should be? How is this field even evolving?
Yeah, that's a great question. And I think the answer is what you just said. It is evolving, right? So initially, as data science was recognized as just pervasive in every field, not just the STEM fields. I saw an English lit person is here in the audience. I think that's awesome because there's digital humanities, there's social sciences, right? Data is now being incorporated into every field, not just the STEM fields. And so there's this kind of dual push and pull between, well, we almost need to treat data literacy and data science like we do reading and writing and math, where it's a basic skill that is just incorporated in all of your education. But at the same time, more and more now, there are universities and colleges that are creating departments or schools of data science. And those two are not mutually exclusive, right? There's this frustration, I think, where people say that, well, data science is foundational. It's not its own department. Well, math has a department. So you can have a department of data science and still recognize that data science skills should be taught across the campus. And so I think we're going to start seeing more and more of that growing momentum of technology, data literacy, data skill sets being integrated in every single discipline, but at the same time, the foundations of data science might start being housed in true academic units like departments and schools. I don't know if that answered your question.
That's great. And yes, digital humanities. That's how I got started, was the digital humanities. Greg, one of your nearby neighbors at Winston-Salem, one of my BFs in data science, they said that Winston-Salem State University, they've infused data science into some classes and established a minor. What are the next steps now that you have the minor? What to do now?
Well, first of all, that's going to be a high success of finding employment, okay? Particularly in areas that are well served, like the Piedmont in North Carolina, RTP. The issue, though, if you do have a data science degree, the less well-served areas where we all, particularly HBCUs and TCUs, are familiar with, they need you even more to help the entrepreneurship. The next step is actually job creation and workforce, what I said. You yourself are well fine because you're a card-carrying member in a very what do they say, a very coveted document you have in your hand. But so we hope that as you advance in your career, who asked that question, that you would help others and expand the populace that can also have those credentials.
Great. And thank you for that. And somebody says, can you make the recording available? This will be on YouTube and also on Facebook. The person says, I'm at Norfolk State University in HBCU and interested in applying for a grant to do modeling and environmental data. I can't talk, sorry. Environmental studies with data science with the team for the mathematics department. Crystal, when you think about somebody who's launching into data science within environmental studies, strong flavor, what should that look like? What are some essential characteristics that you would like to see?
I think there needs to be a reflection as to how they see their work oriented to either their own goals or the goals of the community, and when we talk about community, we're talking locally with the people that we are in community with, and also with the larger global community as well, right? And really making sure that we're making the distinctions clear about how data is constrained, because sometimes data can be a benefit to like the worldwide global atmosphere and climate and global changes, but also, we also have to make sure that we're holding secure our relations to the people that we are held accountable to, right? So having a clear sense of justice and advocacy and for whom and for why, I think is absolutely essential in these spaces.
Great. Thanks so much. Really important considerations. And so thank you all panelists for sharing your insights about data science, how it traverses all the fields, and health informatics. So yes, health informatics, you're in the data science bucket as well. We're all doing this data thing together. And so thanks again to these esteemed panelists for sharing your insights, sharing the information. And I hope everybody has a great rest of their day. See you next time, actually next year.
Thank you.
Thanks all.